Hi guys, now we are going to see code converter. In that we are going to see BCD to X3 code converter. What is BCD? BCD stands for binary coded decimal. BCD is a numeric code in which each digit of a decimal number is represented by a separate group of bits. The most common BCD code is 8421. Now let's move on to the circuit diagram. I have already connected the circuit. The BCD circuit consists of 4 inputs and 4 outputs, and it consists of NOT gate, NAND gate and OR gate. From the truth table, we know if all the inputs are 0, the output will be y equal to 1 and z equal to 1. The inputs are called as A, B, C and D, and W, X, Y and Z are the outputs. What if D is 1 and the remaining inputs are 0? The output will be X, which is X is equal to 1 and the remaining outputs are 0. What if C is 1 and D is 0? The output will be X and Z, that is X and Z equal to 1 and the remaining two outputs will be 0. What if C and D is 1 and A and B is 0, the output will be X and Y. What if all the inputs are 1, the output will be W and Y. The remaining two outputs will be 0. If all the three inputs, that is D, C and B is 1 and A is 0, the output will also be the same, that is W1 and Y equal to 1. If A is 1, B is 0 and C is 1 and D is 0, the output will be 1 except Y. That is Y equal to 0, W, X and Z will be 1. What if is A is 0, the remaining three output is 1, the output will be Y and W. If A is 1, B is 0 and C is 1 and D is 1, the output will be 1 except Z, that is W equal to 1, X is equal to 1 and Y equal to 1. We can do switch on and off according to the truth table. Thank you. Now we are going to see the XS3 to BCD code converter. What is XS3 code? XS3 code is a modified form of a BCD number. The XS3 can be derived from the natural BCD code by adding 3 to each coded number. Let's move on to the circuit diagram. I have already connected the circuit. The inputs are called as XS3 and the outputs are BCD. The XS inputs are W, X, Y and Z and the outputs are called A, B, C and D. The XS3 to BCD code converter consists of AND gates, NOT gates and OR gates. From the truth table, if all the inputs are 0, the output will be B equal to 1 and D equal to 1, the remaining other two outputs will be 0. If Z equal to 1 and other three inputs is 0, the output will be B and C, which is B and C equal to 1 and other two output will be 0. If Y equal to 1 and Z equal to 0 and other two inputs also 0, the output will be B, C and D, which is B, C and D equal to 1. The last input, that is A, is equal to 0. If Y and Z equal to 1 and the other two inputs is 0, the output will also be 0. If X is equal to 1 and the other three inputs are 0, the output will be 1, which is in D. D is equal to 1 and the other three output will be 0. If X is equal to 1 and Z equal to 1, the output will be C, which is C equal to 1, the other three outputs will be 0. If X is equal to 1 y equal to 1 and z equal to 1, the output will be b, which is b equal to 1, the three outputs will be 0. If double equal to 1, x is equal to 0, y equal to 1 and z equal to 0, the output will be b, c and d, which is b, c and d equal to 1, and the last, that is a, is equal to 0. If double equal to 1, x is equal to 1 and y equal to 1, z equal to 0, the outputs will be a, c and d, which is a, c and d equal to 1, the remaining output b is equal to 0. If all the inputs are 1, the output will be a and b, that is a and b equal to 1 and the other two outputs will be 0. If double equal to 1, x is equal to 0, y equal to 1 and z equal to 1, the output will be a, which is a equal to 1, other three outputs will be 0. Likewise, we can do furthermore using truth table.